Hello everyone. In this video, I am going to be explain demultiplexers concept. Okay. So, demultiplexers are the part of combinational circuits. So, in earlier videos, we observed what are combinational circuits and examples of combinational circuits and some other combinational circuits we explained. So, those are in sequence one by one. So, at starting, half adders, full adders, half subtractors, full subtractors, magnitude comparator, decoders, encoders, multiplexers. So these concepts in earlier sessions we covered. So in this video, now I am going to be explain about demultiplexers. As a first thing, these are also under the part of combinational circuits. Okay, let's start about in detail about demultiplexers. Anyway, before starting demultiplexers, these are just opposite functions of multiplexers. These just opposite functions of multiplexer. So, because of that reason, a small recap about multiplexers. So, multiplexers consists 2 power n input lines and 1 output line. Okay, so the processing of these 2 power n input lines based on selection lines. Here the number of selection lines are n. Number of selection lines are n. Therefore, this type of multiplexer we are calling as 2 power n is to 1. So 2 power n are the inputs and 1 is the output. Here n is the number of selection lines. Okay. Based on these selection lines values, which input that is going to be processing. So that is the concept of multiplexers. Now in this video, the demultiplexers concept is exact opposite of that multiplexers. Anyway, what are the examples of that multiplexers are 2:1. Now we can see in this figure it is showing 2:1 multiplexer. So 2:1 means 2 power 1 is to 1. So the number of inputs are 2 power 1. So that is 2 inputs and 1 output, and number of selection lines are 1. Now here it is the selection line. So here I am taking some selection line is indicated with some yes. So if it is a one selection line, it have two options. S value either it is 0 or 1. If S value is 0, then I0 is going to be processing. If S value is 1, then I1 is going to be processing. Okay. So it is an example of that 2:1 multiplexer. The same concept can be available for 4:1 multiplexer also. 4:1 multiplexer. 4 means 2 power 2:1. So here the number of inputs are 2 power 2, that means 4. The number of outputs are 1. Number of selection lines are 2. So the corresponding 4:1 multiplexer is here. So now see, it is 4:1 multiplexer. The number of inputs are 4. Those are I0, I1, I2, I3. And here this one indicating output Y. 4 means 2 power 2:1. So 2 power 2:1. Here this 2 indicates selection lines S0, S1. Based on these selection lines values, the corresponding input is going to be processing. Okay. So it is 4:1 multiplexer. The same concept can be applied for 8:1 multiplexer, like that 16:1 multiplexers also. Anyway, we completed those concepts in earlier. So now we are going to be about demultiplexers. Demultiplexers. So these are just opposite functions of that one. So that means if it is a multiplexer 2 power n is to 1, If it is a demultiplexer, it is multiplexer. If it is a demultiplexer, 1 is to 2 power n. 1 is to 2 power n. Okay, so that is demultiplexer. Okay, so one input, 2 power n outputs based on selection line values. Anyway, that one input is going to be distributing among the one of the output lines. Therefore, these demultiplexers also called as data distributors. Data distributors. Okay, so this can be abbreviated as DEMUX. This can be abbreviated as DEMUX. Multiplexer is MUX. These multiplexers are DEMUX. So now see. The data distributor, known more commonly as demultiplexers. In short way, these can be abbreviated as DEMUX. The function of DEMUX, exact opposite of multiplexers, learned at earlier classes. So now see, demultiplexer takes one single input data line and then switches it to any one of the individual output lines one at a time. So it takes one input line and it can be distributed to any one of the output lines. Okay, so therefore, because of one input line, the data coming as serial and it can be distributed among one of the outputs, therefore parallel outputs. Okay, serial data and coming to that parallel. So therefore it can be called as serial to parallel conversion. It can be calling as serial to parallel conversion. Okay, so now we will go for that analysis. So first we will see what are the various examples of demultiplexers. Now it is the left side figure. It is 1:2 demultiplexer. 1:2 demultiplexer. It can be written as 1:2 power n. That means here this one indicating number of input lines. So input lines only one and two output lines y1, y2. So 2 can be written as 2 power 1. Therefore, here this 1 indicating number of selection lines. Therefore, the number of selection lines are only 1. Okay. Now, based on these selection line value, the data is forwarding to the corresponding output. If selection lines is 0, then input is forwarding to y1. If selection line is 1, then input is forwarding to y2. Okay, so like that. Next, we will go for in detail. Okay, so next 1:4 demultiplexer. 1:4 demultiplexer. Here number of selection lines are 1. Number of input lines are 1. Number of output lines are 4. 4 can be written as 2 power 2. Therefore, this 2 indicating number of selection lines. Okay, now here number of selection lines are 2. So number of inputs are 1, number of outputs are 4, y0, y1, y2, y3. Number of selection lines are 2. So like this, the same concept can be extended for 1:8 demultiplexer. Like that, 1:16 demultiplexer. In case of 1:8, number of selection lines are 3 In case of 1:16, the number of selection lines are 4. Okay, so we will go for that in detail about especially that 1:4 demultiplexer at starting. Later we can go for 1:8 and 1:16. So now understanding of 1:4 demultiplexer. As I shown to you earlier, it consists one input and four outputs and two selection lines. Two selection lines. Here, these two selection lines control these switches. Control these switches. So now see here two selection lines, therefore those are B and A. If A and B are 0, 0, then the common input value is forwarding to A. Why? Because if A, B are 0, 0, then this switch is closed. Then input is forwarding to A. Okay, so that I will be show to you. So now see, if A and B values are 0, 0, then input, the switch is closed, then input is forwarding to A. And one more option for A and B values are 0 and 1. At that time, the second switch is closed, then input data is forwarding to B. So it is second case, it is first case, now it is second case. Like that, we have one more option for A and B values like 1 and 0. If A and B values are 1 and 0, then third switch is closed, then data is forwarding to C. Okay, we will get one more option for A and B values. Those are last option, both are 1, 1. If both are 1, 1, A and B values both are 1, 1, then input data is forwarded to D. So like that, we can understand the concept of 1:4 demultiplexer. So anyway, the number of inputs are only one. It can be processed to one of the output lines based on selection line values. Okay, so next we will go for that detailed analysis part of these cases one by one. So that 1:4 demultiplexer, as I explained to you, one input, four outputs, number of selection lines are 2. Based on the selection line values, the input data is forwarded to among any one of these. Okay, so whatever previously we understand, that one as a truth table now. Now see, if here selection line values are indicated with S0 and S1. If both are 0, 0, then A is forwarded to Y, sorry, then A is, if both are 0, 0, then A is forwarded to Y0. Y0 is at here. So now see, if both are 0, 0, then A is forwarded to Y0. If S0 is 1 and S1 is 0, then A is forwarded to Y1. That case is represented at here. 0 and 1 case, then A is forwarded to Y1. Next, if S1 is 1, S0 is 0, then A is forwarded to Y2. So that's see, S1 is 1, S0 is 0, then A is forwarded to Y2. Okay, the last case, if both are 1s, then A is forwarded to Y3. So both are 1s, then A is forwarded to Y3. Okay, so like that, we can get the truth table for that one. Okay, so now we will write the corresponding output values as a expressions. So those are Y0 value, Y1 value, Y2 value, y3 value in terms of s1 and s0. So those things, y0 value. So now see, when y0 is enabled means whenever s1 bar and s0 bar and a. So y0 equal to s1 bar s0 bar a. y1 is s1 bar s0 a. Next y2 is s1 s0 bar a. Therefore it is. Then y3 is s1 s0 a. s1 s0 a. So now these are the expressions for demultiplexer outputs y0, y1, y2, y3. Then we will go for the design of these demultiplexers based on these equations. So how we will get that one is simply there is some a, there is some s1. So here it is a, here it is s1, like that. Here there is some s0. For suppose y0 is s1 bar, s1 bar and s0 bar and a. These three are multiplied. For multiplication we know there is a AND gate. Like that we will get y0. Like that the remaining also. Anyway, I will show to you the corresponding diagram. So these are the equations and the corresponding design. By completing this one we can get. So the same thing. So now these are the expressions for y0, y1, y2 and y3. Based on these expressions, the corresponding diagram is now see. Here it is input A, selection lines values S1, S0. Now see, here it is y0. We know y0 is S1 bar, S0 bar A. So therefore it is A. Here it is A. Next, S1 bar, S1 bar is this one. S1 bar. Next it is S0 bar. It is S0 bar. S1 bar. Here it is S0 bar. So S1 bar, S0 bar, A. So then we can get Y0. Similarly, in the same manner, by using this expression, we can get Y1. Next Y2. Next Y3. Therefore, it is the design part of that demultiplexer. 1:4 demultiplexer. The same concept can be extended for 1:8 demultiplexer. Here 1 is the input and 8 are the outputs. 8 can be written as 2 power 3. So here 3 are the selection lines. So that corresponding diagram is, so now see, 1 is the input, 8 outputs. These are 8 outputs and 3 selection lines. The corresponding to table. So now it is the corresponding to table for that. So just observe. So here in that two table, the inputs S0, S1, S2. Because of three inputs, those values are varying from all zeros condition to all ones conditions. Whenever all zeros condition, this A can be forwarded to Y0. See, A can be forwarded to Y0. Like that, the remaining, whenever all ones condition, then A is forwarded to Y7. So like that we can get all this. Whenever all are ones, then A is forwarded to Y7. Like same as 1:4 decoder. Then in the same manner we can go for expressions for Y0, Y1, Y2 like that Y7. In terms of S0, S1, S2 and A. So those things I will be show to you. that analysis part. Y naught equal to S naught bar, S1 bar, S2 bar, A. In the same manner, the remaining, like that, Y7 equal to S naught, S1, S3, A. Once if you get these equations, then easily we can draw the corresponding design part. Here I am showing the corresponding design part. Now see, it is A input selection lines S0, S1, S2. Those complements, here S0, here it is S0 bar, here S1 bar, S2 bar. For suppose for getting Y0, S0 bar, S1 bar, S2 bar, A. So S0 bar, S1 bar, S2 bar along with A. Then we can get Y0. In the same manner, Y1, Y2, Y3, Y4, Y5, Y6, Y7 case, S0, S1, S3, sorry, it is a typing mistake, it is S2, A. So S0, S0, S1, S2 along with A. Then we can get Y7. Therefore, it is the design part of 1:8 demultiplexer. The same concept can be extended for 1:16 demultiplexer also. Okay, so that one again here I will be show to you. Before going to that, how that 1:8 demultiplexer can be obtained by using 1:4 and 1:2 demultiplexer. First we will see this one. Later we can go for 1:16 demultiplexer. Now understand. Now the concept is 1:8 demultiplexer by using 1:4 and 1:2 demultiplexer. So now see, now it is. So we need 1:8. So that means one input. That input is here. 8 outputs. Now observe 8 outputs: Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. 8 outputs. Okay, and 8 can be written as 2 power 3. So therefore 3 selection lines. Those 3 selection lines are S0, S1, S2. Now understand, here it is 1 into 2 demultiplexer. These two are 1 into 4 demultiplexers. Then simply the diagram is like this. Then how it is functioning is, we know here it is 1 selection lines. Whenever it is 0, then the data can be forwarded to lower part. Whenever it is 1, the same data can be forwarded to upper one. Whenever it is one case. Now here we have two control signals. Those are S0 and S1. If S0 and S1 are both are zeros, then Y0 will be selected. If both are ones, Y3 will be selected. Like that in this case also. If S0 and S1 are both are zeros, Y4 will be selected. S0 and S1 both are ones, Y7 will be selected. Anyway, it is simply the design part of, so that 1:8 demultiplexer with 1:4 and 1:2 demultiplexers. Okay, so it is simply that part. Anyway, so next we will first go for 1:16 demultiplexer. Again that can be implemented by using again same 1 into 2 and 1 into 8 demultiplexers. So first we will start 1:16 demultiplexer. We already know how the functioning of that 1:4 and its analytic part and its truth table, and also we completed the analytic part of 1:8. Okay, the same concepts can be extended for this one also. Here number of inputs are 1, number of outputs are 16. 16 can be written as 2 power 4. So selection lines are 4. Those can be written as S3, S2, S1, S0. The corresponding diagram, see, input is A and selection lines are S0, S1, S2, S3. Outputs are these. So based on the selection lines values, A can be forwarded to any one of these. Okay, so by knowing that one, we can easily get the corresponding truth table. Now see, if all are zeros, then A can be forwarded to Y naught. We know that. So A can be forwarded to Y naught. The same sequence happens here like this. If all are ones case, the A can be transferred to Y15. So A can be transferred to Y15. Then easily we can get, by using this truth table, the corresponding expressions like as earlier. So Y naught is A into S naught bar, S1 bar, S2 bar, S3 bar. Okay, like that the all remaining cases. Next, in similar manner, Y15 case. Okay, so easily we can get. Once by knowing all these expressions, then we can easily draw the corresponding design diagram. Now it is the design diagram. Here Y naught is A, S naught bar, S1 bar, S2 bar, S3 bar. Simply by connecting to the corresponding inputs. Like that, remaining also. All these Y15 is A into S0, S1, S2, S3. Okay. So this concept is just extension of your hours 1 is to 4 and 1 is to 8. Okay. Once by knowing the concepts of these, then easily we can draw for anyone. Okay. The same concept. So anyway, it is about 1 is to 16 demultiplexer. Later we can go for the 1 is to 16 demultiplexer design by using 1 is to 8 and 1 is to 2. Like as your earlier manner, at starting here 1 is to 2, here 1 is to 8. So here 8. So here 8 plus 8. So total is 16. Here 2 selection. So here it is 1 is to 2, here it is 1 is to 8, here 1 is to 8. Okay. So next, about selection lines, we need 1 is to 16. 16 is 2 power 4. So totally 4 selection lines. Totally 4 selection lines. So out of 4 selection lines, 1 is at here, remaining 3 at here. Those 3, same 3 here. Okay, so here it is S3, these are S2, S1, S0. The detailed diagram here I am going to be showing to you. So now see, number of inputs are 1, here number of outputs are 8 plus 8, total 16 outputs. Now understand, number of inputs are 1, number of outputs are 8 plus 8, 16, number of selection lines are 4, S3 here, S2, S1, S0. Okay. So now it is, whenever S3 0, then the input is forwarded to here. Whenever S3 is 1, the input is forwarded to here. Next, based on these selection lines, the sequence will be selected. Now it is the concept of 1 is to 16 demultiplexer design by using 1 is to 8 and 1 is to 2. Anyway, the conclusion about this video is, we started how the functioning of demultiplexer. It is exact reverse functioning of multiplexers. Later we observed some examples of demultiplexers. Those are 1 is to 2, 1 is to 4, 1 is to 16. Okay, after that detailed concepts of how that functioning and its analytic part and its truth table and its equations, and finally design of 1 is to 4 and 1 is to 8 and 1 is to 16 demultiplexers we observed. Finally 1 is to 8 is designed with 1 is to 4 and 1 is to 2. And in similar manner 1:16 is also designed with 1:8 and 1:2 demultiplexers. Okay, thank you for watching. In my coming videos I will go for that sequential circuits. Okay, thank you one and all.